All right, so next up is electron affinities. It gets the symbol EA, and it's basically the energy released upon addition of an electron. So it's energy released because an electron by itself is in a pretty high energy state. And so anytime you can attach it to an atom, you're generally going to release some energy. It's going to be a more favorable process. And so this trend is actually going to have a lot of exceptions in it. So we'll learn the general trend, and then we'll learn 2 exceptions. But other than that, we won't pay attention to it too much. And then later on, we're going to learn a trend called electronegativity, and that's going to be much actually more useful than this. So I'm not a big fan of these electron affinity trends, but it is actually cool, and some of the exceptions are very cool to look at. So let's look at the overall trend first. The first thing we have to note is that halogens already have a filled valence shell, so they generally don't want electrons, or not the halogens, the noble gases, my bad. So noble gas, right? Filled valence electrons don't want an electron. And then after that, the overall trend, and going from left to right and bottom to top, is that we release more energy. That we're more electron affiniated, that we want an electron more. And the reason behind this is very kind of similar but opposite to ionization energy, right? Ionization energy was how much energy it takes to remove an electron. Here is how much energy is released when we gain an electron. So they're essentially the opposite with the top right, kind of with fluorine over here, really wanting that one extra electron so it can become a noble gas. So again, the top right is the more electron or higher electron affinity. Bottom left is less electron affinity. The 2 exceptions I want you to kind of make note of here is going from here to here. You don't see that trend. And again, that has to do with the 2s and 2p orbitals. Right here, we don't really want to add an electron because this 2s orbital is in higher energy than the other one. And then the other exception over here is with this group 15 and 16. The trends aren't exactly kind of what we would expect them to be. And that's because of these p electrons, right? We're going to have to start pairing them up. And when you start pairing electrons up, we have some electron-electron repulsion, which is not quite as favorable.